Hello, everyone. My name is Dan Jonas Roach, and I am the news editor here at the Architects newspaper. I'd like to welcome you all to the Decorative Concrete as a Design Solution live webinar, a CE Strong webinar series powered by the Architects newspaper. This webinar is sponsored by True Form Concrete. This program is registered with the AIA CES for continuing professional education. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. This webinar is recorded and can be easily replayed when re-registered on the same webinar registration page. Please allow 7 business days to process certificate of participation and AIA credit reporting for this presentation. Now, I'd like to introduce you to today's presenter, Victoria Engels. Victoria Engels is the Director of Commercial Sales at Trueform Concrete, where she leads the charge in delivering innovative, decorative concrete design solutions to teams across the U.S. With over 20 years of experience in the materials industry, Victoria is a passionate advocate for U.S. manufacturing. Trueform excels in helping architects and designers meet diverse design and project requirements, whether for large-scale developments or smaller projects. Victoria is deeply interested in the impact of manufacturing and materials on the environment and is dedicated to promoting mindful manufacturing practices that minimize the environmental footprint of both manufacturers and their products. Remember to please leave your questions for the speaker in the Q&A button found at the bottom of your Zoom window. And without further ado, Victoria Engels.
Thanks, Dan. Hi, everybody. It's a pleasure to be here today. Bear with me one moment while I share my screen. All right. Like Dan said, my name is Victoria. I'm the commercial sales director for Trueform Concrete. We are a New Jersey-based decorative concrete manufacturer. And today's CE is going to be an overview of decorative concrete. Today, we're going to give you an introduction of decorative concrete, an introduction into GFRC, which is also called decorative concrete. I'm going to lay out the case for it playing an essential role in the modern built space. And I'm going to provide you with an explanation of what GFRC is, an overview of GFRC as a design solution, methodologies for fabricating and manufacturing decorative concrete, and finally, an understanding of responsible manufacturing processes. A great place for us to explore our conversation about decorative concrete is by highlighting what decorative concrete is not. It's not the typical concrete that you find at a home improvement store or at a job site. Typical concrete is composed of 3 basic ingredients: Portland cement, water, and some sort of rough aggregate, usually a sand or various sizes of rocks. These ingredients are all mixed together and spread within some sort of formwork. The system is then left to cure for a specified amount of time. At its core, typical concrete is incredibly useful and has a number of functional applications, but there are some key limitations with concrete. First, well, typical concrete has an incredibly high compressive strength, meaning it can handle a lot of weight pressing down on it. It has very low tensile strength. Tensile strength is the measure of how much force concrete can withstand before it breaks. Because of this, if concrete is cast too thin, it often does not have the strength to support its own weight. This can cause cracks in the concrete and can lead to failure. Second, typical concrete is simply not malleable enough to achieve highly refined decorative pieces for the built environment. And by default, because of the ingredients, it's typically warm gray and colored. So you're not going to be able to create objects that are white. However, there have been many adjustments and improvements to mix formulations throughout the years, and GFRC is going to be one of those improvements. GFRC stands for glass fiber reinforced concrete, and I'm going to be using that term interchangeably with decorative concrete throughout this presentation. GFRC is a high strength derivative of typical concrete that has improved upon several of its deficiencies. So what is GFRC made of? At its foundation, decorative GFRC typically uses an artisanal quality white Portland cement. This provides opportunities for pigmentation, and we're going to get to that in a few slides. There's also a substitution from the larger aggregate in standard concrete to a finer, more homogeneous type of sand. GFRC also contains acrylic polymers, which improve the curing time and increase the flexibility of the cured piece. There are several other additives that can alter the mix rheology and working time and make it a better crafted material. And last but not least, GFRC is loaded with glass fibers, which when cured, create a network of connectivity, which vastly improves the strength of any pieces. So what does this do? What does this mix do to the material? First, what you're going to notice is how it looks. The transition to that finer aggregate and the white Portland cement means it's going to have a smoother surface and a more highly decorative finish. But really where you're going to find the most benefits is on the inside of the product. Tensile strength and flexibility are improved with the addition of those glass fibers as well as the acrylic polymer. And this means that GFRC pieces are far less likely to crack when torque or pressure is applied. Compressive strength also improves by the virtue of the Portland cement increase, and it typically pushes this GFRC into the realm of high performance concrete, which is 6,000 PSI or more. So what that means is that GFRC pieces can be cast thinner than traditional concrete while exhibiting equivalent or greater strength. And the thinner pieces are also lighter. So GFRC improves efficiency really by achieving more than traditional concrete, but with less material. And these improvements have enabled GFRC to emerge as an artisanal quality material for creating objects, particularly in the design space. Because of this combination of functional and aesthetic attributes, GFRC is now used in all sorts of different applications. You can find it on countertops, benches, sinks, tables, planters, indoor and outdoor, and all sorts of other arenas. Decorative concrete is a design solution, and it solves for a diversity of challenges. In contrast to manufacturers who create objects that are standard dimensions, concrete fabricators are extremely nimble and adaptive and are routinely commissioned to create objects that are custom sizes or custom designs. And ultimately, decorative concrete fills a void in the market, providing endless options to designers with which you can commission exactly what you're looking for, and you can create exact size, scope, and dimensions. Decorative concrete has exploded in popularity over the last decade. The right fabricator is going to be able to anticipate the needs of any designer and or the space itself, and able to offer hints and suggestions of how to achieve the desired outcome with a design direction. This is the chief benefit of working with concrete designers. You get to communicate directly with the makers of the products. Overall, concrete is one of the most dynamic and useful crafting materials, and its uses can range from really small decorative objects like jewelry to feats of civil engineering. What we're going to focus on today is non-structural precast decorative concrete for use in the built space arena. I really encourage you all to think about decorative concrete as the chameleon of the design world. It's a material that is so responsive to so many different expressions. I'm going to walk you through some of the ways in which decorative concrete can be used to deliver maximum impact on projects. One of the main advantages of using concrete is the ability to specify just about any color on your object or your surface. Concrete allows designers to push the boundaries in ways that other stones or materials simply can't match. On the left is a custom countertop in the color Miami green, and on the right is a complete wraparound commercial bar in bubblegum pink. I want to call out that these objects are not painted or finished in any way. These colors are integral to the pieces. Integral color is possible because concrete starts out as a mixture, and any combination of pigments can be added to the mixture prior to casting. These pigments become evenly dispersed throughout the entire object, which is a phenomenon referred to as through color. You hear the same technology in through color porcelain tiles. And this through color offers an astonishing array of color possibilities. Many GFRC fabricators are going to offer a range of standard colors, but concrete can cast the vast majority of visible colors. Many fabricators will match any paint swatch, which means you can really rely on a range of design flexibility when you choose concrete. Decorative concrete relies on an additive fabrication process that requires forms and molds. For custom work, these forms are built and assembled on a per project basis. This is what differentiates concrete fabricators from other types of manufacturers. It's also what enables the fabricator to create one-of-a-kind pieces that can serve as the focal point of a room or deliver an unexpected design element to a project. In these photos, you'll see an artisan finishing a fiberglass sink basin on my left, and that will go on to yield this shape on the right. So the left is the mold, the right is the shape that mold will yield. Another advantage is that concrete gives designers the ability to specify objects made to exact dimensions. Fabricators can create precast objects and deliver or install them on site. And this minimizes the need for messy on-site building or cutting. And another benefit of decorative concrete is the ability to create a sink with an unusual dimension, like the one pictured here. So standard sink bases, but with an overall length that is an unusual size. Utilizing concrete allows the creation of objects that address very specific functional needs. The large workstations shown here needed to appear both iconic and integral to the room while providing flexibility and mobility for the employees. The exact sizes, shapes, colors, knockouts, and workstations were all calibrated by the designer and built by the fabricator in order to achieve a specific desired result. This would not have been possible using off-the-shelf solutions. Concrete also excels in offering unique or custom finishes. With other stones, the finishes are often limited because they're dictated by the manufacturer's equipment. You've usually got options that are something like glossy or tumbled, but it rarely extends beyond that. Concrete provides far more flexibility because each piece is crafted in-house, and the fabricator can use different casting and finishing materials to tease out different visual and textural expressions of the concrete. Some fabricators enhance the surface even further by applying a faux plaster finish or glazing in an antique finish. Until the concrete is sealed, it can be subject to a number of creative techniques. And the aesthetic results tend to be far more nuanced than natural mass-produced finishes because they are a product of chemistry on the concrete's surface. Pictured here are just 3 of an infinite number of finish possibilities. Concrete is ideal for designing over large or complex surfaces for a variety of reasons. Seams present challenges for those using stones that have a pronounced grain, such as granite or marble, because the change in grain can create visual discord. First, concrete can be cast in exceptionally long pieces, and they can be cast as a single dynamic piece featuring angles, curves, L shapes, or all sorts of other variations. And depending on the project size and the egress into the building, they can be cast with no seams at all. And second, seam locations are not restricted by slab size, but are instead determined by the fabricator. The right fabricator will place any required seams in strategic locations to ensure a successful installation while minimizing any aesthetic disruption on the surface of the product itself. And decorative concrete, again, is a chameleon of the design world. It has the ability to take on all sorts of shapes and textures in forms and molds. And that paired with the receptiveness of surface treatments means that it can take on an astonishing array of appearances. The image on the left here is actually concrete, and the image on the right illustrates how the right artisan can create a very convincing take on marble simply by sprinkling some pigments into a form before the decorative concrete is cast. Oh, sorry, can't get my page to turn. Concrete is often used to create seamless objects. Seamless objects offer several advantages over objects that are assembled from components. If you take this sink, for example, it's inherently stronger due to its lack of miter welds and is not going to be subject to leaking or separating. It's convenient in that there's no need to adhere an undermount basin. It's easier to clean and is more hygienic because there are no seams or crevices for microbes or molds to inhabit. The seamless sink presents beautifully and has a bespoke and high quality appearance as well. Sorry guys, having a teeny tiny issue getting these to move forward. There we go. Decorative concrete also enables architects and designers to consider or specify integrated features that are part of or continuous with a piece. You can think about this as if you're baking intelligence into a piece that solves a specific problem. GFRC integrated features give designers an opportunity to design with intent. And here are a few examples of that. The image on the left shows an outdoor custom countertop with a fire feature directly on top of the countertop. While on the right is a countertop with an integral drain board, which ramps to the sink. Oops, excuse me. Bear with me one moment. I apologize. Looks like, sorry, everybody. Having just a little bit of a technical issue here. I apologize. Let me get to the right page. All right, we covered integrated features. Now let's talk about curvature. Thanks for your patience, everyone. We're often used to seeing concrete designed with right angles or honed into pointy and boxy shapes. Concrete can be cast against curved molds, which yields very graceful pieces in panels like the one curated here. Of course, other stones can be cut into curvy shapes, but those shapes and sizes are usually limited by that source slab. The constraints of slab size do not apply to decorative concrete. The panels crafted for this serving station here were about 1 inch thick, meaning that the entire interior of this piece is hollow. That enabled the station to be transported to the final installation site, which is a rooftop. Concrete is essentially a liquid cast against a form, and it's receptive to adopting all sorts of patterns and shapes and contours. And although you can cut or carve other materials using reductive methods like a CNC machine or water jet cutting, these methods typically require shipping the pieces to a specialty manufacturer, which adds a significant amount of time. It adds complexity, and it can add cost and risk to the project. CNC is commonly used for creating shapes and patterns for concrete pieces, but the difference here is that these methods are applied to the forms and not to the actual stone or product itself. Once the form is created, it can be used to cast multiple concrete pieces. And for projects involving numerous copies of the same object, using concrete can save a tremendous amount of time and money versus reductive methods. This is a really wonderful example of the level of detail and complexity you can get with custom GFRC. What you're looking at is a showcase concrete sink that has been cast into a topographic map of a place called Mandeville Canyon in California. It's definitely not the most efficient water egress system, but it really is more of an art project than anything else. It really serves as an example of how customizable decorative concrete really is. Another advantage to concrete is that inlays can be added to the mix prior to curing. Once the top layer is polished, the inlays are continuous with the surface, and this can yield objects or surfaces with a variety of integrated materials like glass, wood, metal, and others. And it's a clever and beautiful way to accent or personalize a project. Terrazzo is another practice in decorative concrete, and it's the practice of employing large aggregate of specific colors, typically chips of marble, granite, or glass, and making them visible on the surface. This results in vibrant, complex patterns, and it appears both controlled and random at the same time. Between the choices of aggregate and the ability to define the color of concrete itself, there are an infinite amount of potential terrazzo color combinations. Another interesting design possibility with decorative concrete is the ability to add graphics, words, or design elements. This can be accomplished by applying a stencil to the surface and then acid etching that intended area, which makes it more porous. The stenciled portion is either stained or painted and then coated in a topical sealer. Ideally, this is going to be done by your original fabricator and someone who understands the material of the product the best. So we just walked through some of the ways that GFRC can act as a design solution. I'm now going to walk you through the process of how GFRC transitions from an idea into a product. And please note that every fabricator has slightly different processes, but the steps outlined here are going to be more or less universal. Concrete fabricators can really function differently from one another. Some produce standard products day in and day out, and others create just one-off custom pieces. But no matter what the fabricators produce, they need specifications to begin each project, typically in the form of a technical drawing or a standard purchase order. Because formwork will need to be selected, assembled, or built, specifications are going to act as plans. These are going to capture essential information for each phase of production. Once the plans or instructions are received, these specs are then taken to the manufacturing floor and referenced while building out the formwork. GFRC is typically cast in the reverse direction, meaning that the concrete will take on the shape and texture of whatever it's being cast against. So before pouring or spraying can begin, molds or forms must be produced. A form can be regarded as the negative of the finished piece because the goal is to yield the positive, which is the finished concrete piece. If you think about it this way, if your goal is to create an ice cube, first you must create the ice cube tray. So these forms and molds are the ice cube tray. Forms are either assembled from modular pieces or created from scratch. Fabricators use a variety of non-porous materials to create forms, and they create them to exact specifications. For standard production, manufacturers will rely on reusable molds and forms, typically made from steel, rubber, laminate, melamine, or fiberglass. And what you're seeing here in this visual are several custom sink forms made out of rubber, which are going to yield several hundred casts each. Batching is next. Batching is the organization of any raw mixed material required to create the piece. Once the forms are assembled, the exact amount of GFRC components is then calculated and measured to minimize waste. The ingredients include color pigments, sand or sands, Portland cement, mixed additives, plasticizers, acrylic polymer, water, and of course, glass fiber. The batched ingredients are then methodically loaded into different types of concrete mixers, and depending on the type of project that's being cast, the temperature, timing, ingredients, and the order of loading these ingredients all create variables and can create challenges to getting the concrete to behave properly. Plasticizers can be used to reduce the viscosity of the concrete mix to a near water consistency without having to add water. The concrete shown here actually has very little water, but it flows that way due to plasticizers. GFRC can be cast using a few different methods. The methods employed depends on a few factors, including the shape and complexity of the piece being fabricated, the desired thickness, the skill level of the fabricator, and the tools at their disposal. One casting method is known as the spray up process. This is where the fabricator uses a chopper gun that mixes glass fiber from a spool with concrete while it's being sprayed into a form. The fabricator is going to take several passes, building up layer on layer to reach the desired thickness. And because longer fibers are used here, this method is going to produce a very strong piece. A second method is a hybrid or spray and lay process. This is a two-layer method. The first layer or face coat is a thin surface layer sprayed with a gun directly into the form. A backer layer of GFRC, a thicker mix that contains glass fibers, is then added behind the skin in order to provide strength and achieve the overall desired thickness. This backer coat is either poured in or hand-packed, as seen in the image on the right. Hand-packed GFRC is thick enough to be sculpted and is often used on pieces with vertical surfaces because it can retain its shape against gravity. And the final method is called wet cast pour, or SCC pour, SCC being an acronym for self-consolidating concrete. With this method, a low viscosity mix is poured directly into a form. This process typically requires some level of agitation to accelerate consolidation and remove air bubbles, as they're going to result in small holes on the surface of the concrete. This can be used, this can be achieved using a vibrating table. Once the concrete has cured to the manufacturer's protocols, the concrete must be removed from the forms. The curing process can take from 3 hours to 3 days, depending on the mix design, the application, the minimum strength of the concrete, and also it needs to be safely removed from the forms. Fabricators are going to take precautions while demolding so they don't damage both the concrete piece or the forms that they're working with in case they need to be reused. The final stage in the GFRC fabrication process, and one of the most important, is finishing or processing. This is where the cured piece is refined and elevated from a rough and raw concrete piece to a functional piece. Because the visible surfaces need to be both durable and aesthetically pleasing, at this step, this step has to be taken by the manufacturer in order to yield a high quality product. The finishing process here is going to vary by fabricator and also depends on the desired application of the piece. Some fabricators prefer to retain as much of the concrete's authenticity as possible, perhaps doing some light sanding, and that's it. Others are going to choose a far more labor-intensive process. A thorough finishing process will include at least these steps. So first you'll have wet polishing, where the piece is smoothed out, sharp edges are softened, and a uniform surface is achieved. Next is filling. This step involves plugging and filling any pinholes on the surface with concrete of the same color, followed by sanding. This is where any plugged pinholes become seamless with the rest of the surface. And finally, sealing, which is the most critical step. Because concrete is inherently porous, it should always be sealed. The material and method used to seal concrete is key in determining how resilient the surface is going to be. This image depicts the same concrete panel, except the right side has been sealed. You're going to notice on the left-hand side that the color seeps into the raw concrete, while on the right side it beads off the surface, and that's because the surface is treated. You're going to notice also that the addition of the sealer enhances the color of the material. A good sealer is going to compensate for concrete's porosity, and for wet applications such as countertops and sinks, a proper seal is critical. It's like the top layer of a clear coat on a freshly painted car. With proper care and maintenance, it's going to last for years. So what do fabricators use to seal concrete? There's essentially two types of sealers: reactive sealers and coating sealers. Reactive sealers are thin fluids that literally soak into the concrete and chemically react with the ingredients. This provides invisible protection without changing the surface appearance. In contrast, coatings are thicker fluids that are rubbed or rolled onto the concrete surface, and which, once cured, form a hard protective surface. Acrylics, urethanes, and epoxies are all the most widely used topicals. They're going to add a little bit of sheen to the piece, and they're going to slightly enhance the color. It's really important to note that all sealers are vulnerable to natural acids. Penetrating or reactive sealers are especially vulnerable, whereas coatings provide a superior protection. Some coatings are prone to scratching, and once scratched, the concrete may be vulnerable to staining. Maintenance and care is important, and so many acids from common foods or beverages should be removed quickly. So things like lemon juice, mustard, wine, vinegar, they may chemically etch over time. This is really similar to granite and to marble. The good news is that coating sealers can be repaired, and entire concrete surfaces can be resealed if the sealer becomes compromised. Decorative concrete's longevity depends on two factors, both the maker and the user. And though it's widely utilized for functional flat surfaces, you're only going to be as effective as the sealer. Improper sealing or not sealing at all is going to invariably lead to issues. So you should always confirm that your fabricator is at least using an industry standard sealer. As far as the user's concerned, common sense behavior and routine maintenance is going to ensure a well-made piece remains beautiful for many years to come. You're going to want to avoid dragging any sort of hard or sharp objects over the surface. And it may seem like a no-brainer, but you'd be surprised how many people ask about cutting foods directly on their concrete countertops. This is a bad idea on any stone surface, and it applies to GFRC as well. It's likely going to both ruin your blade, but it may also scratch that protective sealer, and that makes the concrete susceptible to stains. GFRC is perfectly suitable for countertops. You just need to use a cutting board. It's also advised to avoid environments with a lot of acids or harsh chemicals. Some examples are laboratories or nail salons. Abrasive cleaners and certain solvents can etch or erode the sealer and can lead to stains. If GRC is used in these environments, these chemicals should be removed very quickly or to prevent damage. And while it's quite common for granite countertops, placing hot pans or hot objects on decorative concrete is strongly discouraged. The concrete itself won't get damaged, but the sealer will permanently discolor. So you always need to use a protective surface. And what do you do if your concrete gets damaged? Well, concrete is extremely durable, but it's not bulletproof. Like any other stone material, it's subject to accidents, abuse, or overuse. Fortunately, damaged concrete can be repaired and brought back to life. Surfaces that incur heavy or sustained use, like kitchens or bar tops, might begin to dull over time. And this is an indication that the sealer is thinning out, and it can result in the tiniest of micro scratches. In these cases, the surface can be resealed by either an end user or preferably the fabricator who created the piece in the first place. This entails sanding down the surface and reapplying a fresh coat of sealer. And while most decorative objects may never need to be resealed, some surfaces that incur excessive or heavy use may benefit from resealing every 4 to 5 years, extremely high traffic areas. I want to turn now to a brief overview on the intersection between responsible manufacturing and concrete fabrication. Concrete is the most utilized building material on the planet. By definition, it's going to have a proportionately sized carbon footprint. This has often led to a lot of stigma around concrete. While fabricators can't totally control the raw material chain itself, they can certainly exercise smart methodologies during the manufacturing phase. And they can do so through responsible manufacturing approaches and by the nature of the material itself. Designing with concrete is arguably far more efficient than designing with other types of stones. And let's take a look why. First, natural stones like granite and marble have to be mined or excavated from quarries, typically located in other parts of the world. The stone is carved into massive blocks, which are transported over great distances before being cut into viable slabs by big machines. This is all just to get a few rough slabs. A tremendous amount of resources are required to achieve this, and yet it yields a great deal of waste. In contrast, concrete pieces are made in the fabricator's factory. This process wastes little to no material because ingredients are measured out precisely for each product. There's roughly a 1-to-1 ratio between raw materials and actual output, and this does not hold true for natural stone. For example, a 1-ton block of granite might end up only yielding a few countertop slabs while generating hundreds of pounds of waste. If you consider the creation of a sink, with porcelain being one of the most common materials used, porcelain sinks need to be pressed with heavy-duty equipment and then fired in an industrial-sized kiln at a temperature of about 2,000 degrees Fahrenheit, 2,300 degrees Fahrenheit, for a period of about 24 hours. This requires an astonishing amount of energy that impacts the product's global warming impact. When it comes to concrete, the most of the energy used in the creation of a piece is performed by Mother Nature by means of an exothermic reaction called hydration. The transition from raw liquid-like material into a cured finished product is a function of chemistry. No heat or additional energy is required beyond human movement and some light handheld power tools used to create molds and processing those cured pieces. Additionally, glass fibers used in GFRC are often made from recycled materials. And depending on the manufacturer, glass fibers can be produced using up to 40% recycled glass. There's a handful of other reasons why concrete is a smart choice. First, thoughtful fabricators are going to make the best of their resources. They can choose to recycle any water utilized in the finishing process. They're also going to utilize reusable forms whenever possible. Depending on the material and construction, these forms can yield up to several hundred pieces before needing to be replaced. And finally, choosing a local or American-made product versus sourcing them internationally eliminates the need to ship them from overseas. When added together, these practices are meaningful and effective. There are ways to minimize environmental impact beyond the fabrication space as well. Concrete waste or pieces that are no longer useful can be recycled and used in other construction projects. There are many companies that will take existing concrete, crush it up, and use it for things like bed foundations or trenches. Thoughtful fabricators are always going to choose this route. And finally, I'm sure that some of you are aware of that the creation of Portland cement is a high energy consuming process that uses electricity and emits CO2. To compensate, leading vendors have started to improve their mix formulations by replacing a part of the Portland cement with natural products. Limestone or other industrial byproducts can be used. And this initiative has two separate but important benefits. First, it reduces the amount of Portland cement, therefore reducing total energy consumption in greenhouse gases. And second, these ingredients improve the durability of the end product. Overall, a very strong argument can be made that GFRC is more energy efficient than both typical concrete and other stones due to 4 different factors. First, the reduction in the total amount of material needed per project, since GFRC can be constructed thinner. The need to mix only the amount of GFRC needed for each project, yielding less waste. The movement towards improved formulations with less Portland cement and more limestone. And finally, the use of fibers made out of recycled fiberglass, or recycled glass, excuse me. At this point, I've reached the conclusion of the presentation. I thank you for your time, and I will open the floor to any questions.
Wonderful. Thank you, Victoria. The first question is from Larissa. Do bespoke GFRC forms need to be engineered? An example for thickness. And do fabricators typically provide the service?
Yep, that would typically be provided by the fabricator. Each fabricator is going to have different limitations depending on the mix that they use, as well as the equipment that they use to make the actual end product. So you can ask for specific dimensions, but you may have some limitations in like the thinness a piece can be cast.
Great. And there's a second question from Larissa. How is the surface treated to prevent the glass fibers from sticking up?
That's part of that finishing process. The second method that I talked about, the spray and lay, the face coat has no glass fibers. That's typically what my manufacturing team uses. So you have one thin layer of decorative concrete with the hand-packed GFRC behind it. So you're not going to see a lot of that. Sometimes you will see some of that glass fibers in the surface, and that's part of the overall look, feel, or texture of the finished piece.
Cool. Question from Alice. Can the concrete for GFRC products be specified as low embodied concrete?
I don't know the answer to that. So I can follow up with that question. I'm not sure of the answer there.
Okay. Question from Lisa. Can this material be used in 3D printing applications to eliminate the need for creating forms?
Yeah, so there is very new technology. Bjark Ingels, I'm apologies if I'm saying that wrong. Big out of New York City did do some 3D printing in Texas for sustainable housing. It's very early in the technology phase. We do see 3D printing both in molds and some people doing a very small amount of 3D printing of actual decorative concrete for end use products. There's not a lot of it yet. And I think as the technology improves and increases, we'll see more of that.
Cool. Question from Joe. Can the material be refinished?
Yes. I'm going to combine that with the question below, does it need to be resealed? So both, my answer would apply to both in that there's a thin layer of sealer on the surface. And so you can scarify it or scratch the surface up and reseal it. To be refinished, you would have to sand down the entire surface, but you would not be able to change the color of it. And if there's inherent texture in the product, likely that wouldn't change either. You're only changing the surface sealer.
Another question from Larissa. Is filling of pinholes done one by one?
No, you do that if you think of like putting sand through a screen. So you basically like you fill them all at once and then you sand down the surface of it. So you can. Some manufacturers and fabricators will leave those pinholes exposed as part of the overall look of the decorative concrete.
Question from John. Does the hydrophobic sealer need to be reapplied?
I'm actually not familiar with what hydrophobic means. I don't know the answer to that, but I can get the answer.
Can the same integrated water repellent used in regular strength concrete be used for GFRC?
I don't know the answer to that one either. I'm not as familiar with regular concrete, so that's a good question.
Is GFRC a good material to use for either floor or wall tile?
It's great for wall applications in that there's a little bit of flexibility to it. As for floor tile, you would likely be better off in a high traffic commercial application with something more dense like a porcelain. It can be used in light commercial, very light commercial and residential applications due to slip resistance and some of the ASTM standards around floor traffic needs.
Question from Jorge. Do you know if there is any future possibility for structural use?
I think there are some structural uses for GFRC. However, I am solely an expert on non-structural uses for GFRC.
Question from Jonathan. What are you using usually externally for climates like Canadian winters?
Yeah. So GFRC does wear well in exterior climates. Like any product that would have ice or water sitting on top of it, you want to make sure there's not exposure to that water for freeze-thaw cycles, and it is going to age more over time outside. So you're going to get a weathered look to the product if it's fully exposed to the elements. It's not something recommended for like a roof panel, but you can use the product in landscape architecture products or wall panels. Again, suggested in something with like an awning or a covered area over it.
Question from Richard. Can you speak more about sealants and how they typically age over time in a high traffic situation?
Yeah, so sealants should be applied by the fabricator. The coating sealer, which is kind of the difference of the one that beads up on the surface, is applied with a roller and very often never needs to be resealed or maintained over time. If we're in an extremely high traffic location, say like an airport, which is where I am at right now, you may need to reseal it due to high traffic, and that's where you would scratch it up and reseal it. Or if there's some sort of accidental damage to it, say you drop a large and heavy object on it and you scratch the sealer, it can actually just stain either the sealer or the concrete, and you can scratch up and reseal that area as well.
Great.
But many pieces, sorry, don't need to be, never need to be resealed. There's a high volume due to the quality of the sealer used on that front end.
Great. This may be a similar question, but what is the
Yeah.
recommended maintenance for the two countertop sealer options?
You clean with a pH balance cleaner. So anything you would clean your dishes with, a non-abrasive cleaner. And that's it. That's really the only care and maintenance that you would need.
Cool. Question from Kelsey. Can GFRC be used with pool chemicals? Thinking about application in regard to applications to create pool slides.
I'm not sure of the answer on that one. My guess would be that the chemicals might be too harsh. However, if I think of like the surface around a pool, there's often typical concrete. So it may just be how that's finished. It would be something we'd want to have a conversation about.
Yeah. Question from Tim. Is there a benefit in using GFRC in place of GFRG?
They can be used interchangeably.
Okay. Question from John. Are fabricators easy to find, and are there set standards?
You can find quite a few regional fabricators. Trueform Concrete is a New Jersey-based fabricator who fabricates for products all over the U.S. And though I'd say you can find these across the U.S. definitely.
Cool. Can you talk about the ratio between thickness and span or cantilever applications?
Yes. However, I can speak at a very high level to it, whereas our project engineers that we have in-house would be able to give you the specifics of it. So the longer you would go, the thicker it would need to be. And there's obviously limitations there without any sort of support. So many fabricators, us included, have project engineers who have experience and will help craft any sort of custom interior or piece for an application that has those sorts of like tricky dimensions to it.
Great. Does GFRC weather at the same rate as true concrete?
Because of the addition of polymers and because it's a little less porous, it's not going to weather at the same rate. And if you seal it, it will weather slower. It really depends on how you're treating the finish. You're finishing both pieces. It does weather over time. It's going to weather very well, depending on the sealer that you use and the mix of the ingredients that you put in there.
Great. Is polished surface Do polished surfaces require fine sanding, or can they be achieved just with sealer?
I'd say that the sealer can have a shine to it. I don't know that you ever, without an additional application of additional material, it's not like a super high shine, but there are sealers that have more of a shiny finish to them.
Okay. Is metal reinforcing ever used in special applications?
Yes. It can be, and that would again be part of a combination of crafts working together to create some sort of a custom piece.
Great. Question from John. Where can John find information on types of finishes that are available?
You can go really any decorative concrete manufacturer's site will show you the different types that they offer. Everyone will have different types of finishes that they offer. And remember, really takes on whatever it's cast against. So likely the sky's the limit for your imagination of what that finish and texture could look like.
What is the typical thickness for a roof cornice Say, for example, a 4 foot tall classical Roman entablature style.
That's not the type of product that we manufacture, so I don't know the answer to that.
Okay. Is there already a sealant? If there is already a sealant that is worn out, can you put a coating over it?
You would want to scratch it up and then reseal it.
Okay. And the last question I see is about debossing.
Yep, I see it. So that the California Cannon, that's actually built, that's cast against a mold. So if you think again of like an ice cube tray. So first we build the tray and we can use a CNC machine or even a 3D printing to go back to that to build the mold. And then we cast the decorative concrete against that. And then that the end result is what you see against that.
Great. So we still have about 5 minutes left. If any folks have more questions, I encourage you to put them in the Q&A window. If not, we can wrap things up. Okay. So unless anybody has, oh, it looks like there's a question from Bradford. What would be the advantage of using GFRC over GFRP polymer if the same aggregates can be mixed with similar finish appearances, but with much thinner and lighter products?
I am not an expert in GFRP, so I'm not going to be able to answer that question.
Okay. Does terrazzo finish require grinding?
It does. And that's when you would need to make sure that you have a fabricator who specializes in terrazzo because there's a specific tool that you need to kind of get to that that look and finish, and not everybody does that.
Okay. Is it possible to apply a layer of GFRC to conventional concrete to get a desired finish?
I bet, but I don't know. I can't say with certainty. My suspicion is yes, but I'm not totally sure about that.
Okay. I think that's all of the questions that we have, Victoria, so I'm going to deliver some closing words. Thank
Thank
you
you,
all
Dan.
so much for attending the live webinar, Decorative Concrete as a Design Solution, a CE Strong webinar series powered by the Architects newspaper. This presentation was sponsored by Trueform Concrete. This webinar is recorded and can be easily replayed using the same registration link. Please allow 7 business days to process certificates of participation and AIA credit reporting for this presentation. A big thank you again to our presenter Victoria Engels and to Trueform Concrete for sponsoring this webinar. We hope to see you all again at a future event. Have a great day.